the real life scenarios where people visiting ATM counters, users using a soda or snack machine. There is some theory working behind these scenarios and they are called functions, which is a special type of relations. People used to relate function to a machine where we input some data and the output is taken after performing some functions on the input data. In this figure, x is the input, which is the independent variable, f is the function, and y is the output, which is the dependent variable. So, we can write y is equal to f of x. We will closely look into each scenario which we have discussed earlier. In the case of ATM counter, ATM machine is the function that applies a rule. Here, the card dispensed equals the amount requested. In other words, we can say output equals the input. Similarly, things happen in a snack machine. So, in this video, we are going to discuss about functions and its fundamental aspects. Let's see the mathematical approach. Function f is a relation defined from set A to set B if and only if every element of set A has one and only one image in set B. Note, all functions are relations, but not all relations are functions. Let's see the mathematical representation. If f is a function from set A to set B and a comma b an element of f, then f of a is equal to b, where a is called the pre-image of b and b is called the image of a under f. Now, how can we check whether the given relation is a function or not? We need to check whether each element in the domain points to only one element in the range. Putting more simply, if domain elements do not repeat, then it is a function. Let's see one numerical example. Define the function f of x f such that r to r is given by y is equal to f of x is equal to x cube plus 1, where x element of a real number. Now my question is, what is the domain and range of this function? Take a range of values of x. For example, -2, -1, 0, 1, 2. Now, first draw a table showing the values of x and y. So, when x is equal to -2, y is equal to x cube plus 1. Substituting the value, we get the value -7. When x is equal to -1, we get y is equal to 0. When x is equal to 0, we get y is equal to 1. Now, when x is equal to 1, we get y is equal to 2. And when x is equal to 2, we get y is equal to 9. Substituting the values in this equation. What is the domain? Domain of f of x is equal to -2, -1, 0, 1 and 2. Now what is the range of f? Range of f is given by -7, 0, 1, 2 and 9. Now let's draw the arrow diagram. Mapping is shown here from -2 to -7, -1 to 0, 0 to 1, 1 to 2 and 2 to 9. Learning about functions help to solve real life problems. The electricity bills are examples of functions. They are actually the outcomes of the energy consumption. An electrician charges a base fee of rupees 400 plus rupees 50 for each hour of work. Find the amount of electricity charged for 1, 2, 3 and 4 hours of work. Now another question, is this relation a function? Coming to the solution part, let x represent the number of hours, Y represent the amount charged for X hours. We need to draw a table showing the X and Y values. Here is the table. When X is equal to 1, Y is equal to X into 50, which is 50. Base fee is 400, which is common for all. And the total fee is 450. Now when X is equal to 2, we get corresponding Y as 100. Base fee is 400 and the total fee is 500. When X is equal to 3, we get Y is equal to 3 into 50, which is 150. Base fee 400 and the total fee is 550. Now when X is equal to 4, we get Y is equal to 200, base fee 400 and the total fee 400 plus 200, which is equal to 600. The relation is a function such that Y is equal to X into 50. Mark it as equation number 1. The total fee is equal to Y plus 400. Mark it as equation number 2. So the total fee is equal to X into 50 plus 400. Now you know how to identify whether the given relation is a function or not, and also to draw the arrow diagrams for the same. Now arrow diagram for a relation is given and you are asked to identify whether it forms a function. Refer figure 1. Anna to Jafril, Catherine to Naveen, Dane to Ruba. Is it a function? Think no, right? Why? Here the domain element able is having no image, therefore it is not a function. Refer figure 2. 16 to minus 4 and 4, 9 to minus 3 and 3, 36 to minus 6 and 6. Is this relation a function? No, right? Why? Here the domain elements have multiple images, which is not possible for a relation to be a function. Next, we will discuss about real functions and real valued functions. Consider the example, if f of x is equal to 2x, find the domain of the function f, find the range of the function f. So let's see f of x for some values of r. For value x is equal to minus 1, f of x is equal to minus 2. When x is equal to 7, f of x value is 14. When the value of x is equal to minus 6, we get f of x as minus 12. And when x is equal to 0, we get f of x is equal to 2 into 0, which is 0. Thus we have seen we can use any real number values for x. So the domain of the function is nothing but the set of all real numbers, and the range of function f is again a set of real numbers. Thus a function which has either real number or a subset as its range is called real valued functions. In addition, if its domain is also either R, that is real number, or a subset of real number, then it is called real functions. So we have discussed all the fundamental aspects of functions. Now let's see the graphical treatment for various types of functions in the next video. Now let's have a quick recap of what we have learned.
Manorama Horizon. Learning made simple.